Hi everyone, today we'll be discussing densitometric analysis. So densitometric analysis is a quantitative measure that discerns the optical density of material on a film or image via light transmission, and this can be measured with the densitometer. It was first observed that loss of radiation or light occurs when light passes through a medium, and then that concentration of a substance determines the amount of radiation loss within a medium, aka the optical density. So sample concentrations can be deciphered via optical, electronic, and computer-based imaging systems. We'll be using the ChemiDoc imaging system to perform densitometric analysis.
So how are the density values obtained? Light rays from a light source are passed through a lens and a filter, which focuses specific wavelengths of light onto a printing sheet containing the Western blot image. Some of this light is absorbed and the rest is reflected. How much is absorbed or reflected depends on the thickness of the printed sheet and the nature of the ink. A separate lens captures the reflected light and focuses it onto a photocode. The received light is then converted into a current, which is compared to a reference current. The difference between the two is the value we would see on the densitometer's display. Density itself is not measured by the densitometer. Rather, it's the reflection from the printed sheet that's measured, and this value is used to calculate the density. The formula that we use to do this is density equals log of 1 over r, where r is a reflectance. From the equation, we can see that there is an inverse relationship between density and the reflectance. This inverse relationship between density and reflectance is shown on the graph on this slide.
So the type of quantification that we're doing is that we're comparing the amount of protein of interest, which is PAKT, to the total protein in the sample. And this is important because we first perform a Western blot of total protein in the sample. Then we'll rehydrate the membrane and probe specific antibodies for PAKT. This will generate a lit up blot image that only displays PAKT. So even if we pipette slightly different total protein amounts in each different lane, this variability is accounted for as we're focusing on the ratio between PAKT and the total protein within the same lane.
Density is proportional to protein concentration, so we can use the two blots to find the amounts of PAKT and total protein by comparing their densities. This is a densitometric analysis showing the relative peaks associated with the Western blot. Darker staining is associated with higher peaks, indicating greater amounts of protein. Therefore, we can quantify relative changes in PAKT levels in the different treatments, including media, insulin inhibitor, and the insulin inhibitor conditions.
So in summation, densitometry measures optical density through a medium to quantify the protein on the Western blot. It also lets us account for any loading variability as we use ratios of the protein of interest to the total protein within the same lanes. We can see changes in protein of interest upon quantification and comparing to total protein.
Now is a good time to pause the video and try the questions below. Answers are provided on the next slide. Thank you for listening to our presentation.